In this video, we're going to talk about how to transform an absolute value function. Now, how do I know it's an absolute value function? Notice that we have these vertical lines here. That tells us that's the absolute value. So let's start by drawing the parent function. So our parent function, like in our previous videos, actually, I'm going to do it at the bottom here where I might have just a titch more room. All right, so our parent function is y equals the absolute value of x. I don't have a ton of room here. I'll try and squeeze it in. Okay, so what coordinates are we using here? We're going to use -2, -1, 0, 1, 2. Those are our key inputs. And remember, when we take the absolute value of them, it just changes negatives to positives. So all it does is the negative inputs change to positive inputs, and the positive ones stay exactly the same. And we end up with 5 points that look like this. Now, we could input any points, but those are the 5 key points we generally like to use when drawing this. So I'm going to get out my ruler and draw some lines. Okay, so I've got my function drawn. I've extended it all the way through the grid to show that it continues going. I've included arrows on the end to show that it continues going. Draw straight lines. Don't forget the arrows at the end. Okay, let's get into our transformations here. So remember, we need y equals a, our function kx minus d plus c. All right, so that's our function for the absolute value function with all its transformations on it. So the a is easy to spot. It's out front, right? So there's our a, and our k's not too difficult to spot. It's inside the function. So note, when I say inside, I mean inside the absolute value. So the a is outside, the k is inside. So let's start with the a. A is -2. So as we talked about in the last videos, if it's negative, there is a vertical reflection. So I'll write VR for short. And the 2 part of it, if I ignore the negative for a minute, tells me about the stretch. There's a vertical stretch by a factor of 2. Factor meaning multiplied by here, right? So let's do a table for our stretches and our reflections. So we go a times our y coordinates. So I know I don't have a lot of room here. Hopefully you can make it out. We're going to go -2 times y. So -2 times all our y coordinates. So -4, -2, 0, -2, -4. So I took all my y coordinates here and I just multiplied them by -2. So notice now they're all negative and they're larger. They've been stretched, right? Now the k value here is 2. Now again, we don't work with k, we work with 1 over k. So what we're actually going to have here is 1 over 2. And I got k written here, but what we really want is 1 over k. So 1 over 2, which means we're going to multiply our x coordinates by 1/2. Now, if we had had something like, if k had been something else, let's just talk about it. It'll come up in the next video, but let's just say k was 1/2 to start. So let's say instead of a 2 here, I had 1/2. Well, what would 1 over k be? Right? 1 over k would equal 1 over 1/2. Well, what's 1 over 1/2? That's the same thing as saying 1 divided by 1/2, which is 2. 1/2 goes into 1 twice. So it's just the reciprocal. You just flip it. So that'll come up later, but in case you're wondering, well, what do I do if I have a fraction? You just flip it. It's the reciprocal. Okay, essentially that's what we've done here. We have a 2, but we flipped it. So instead of 2 over 1, it's 1 over 2. Now, there's no negative, so this has no horizontal reflection, which wouldn't have any effect, because if we flip this horizontally, don't we get the exact same V shape if you flipped it around? So it wouldn't have an effect anyways. So you generally don't see a negative there. However, we do have a horizontal stretch by a factor of 1/2. Now, technically, again, this is a compression because we're shrinking the numbers. So let's have a look at what this looks like. Okay, so let's take all the x coordinates, and we're just going to multiply them by that. So 1/2 times the x's. Now, multiplying by 1/2 is exactly the same as dividing by 2. So just divide them all by 2. So I get -1, -1/2, 0, 1/2, and 1. So I took all my x coordinates here, and I just divided them by 2. Okay, so let's plot that and see what we got so far. So our middle is at 0, 0 still. I've got -1, 4 down, -1/2, 2 down, and on the other side, 1/2 over 2 down, and 1 over 4 down. So we're going to get a V shape again. I'm going to get out my ruler and draw. All right, I've done a pretty good job. Might be off a little bit. Sometimes using this program is a little tough to get everything drawn correctly. So now notice what's happened here. We have flipped it vertically. It's reflected. It used to be facing up. Now it faces down. What else have we done? We have stretched it vertically. It's gotten a lot longer this way. And we've also compressed it horizontally. It's been squished in. All right. So let's do the final transformations, which are D and C. So those are these numbers here. So remember with D, we always take the opposite of what we see. So I see -3, so I'm going to make it +3. And the C we take at face value, it's going to be +5. +3, +5. So what do they do? Well, the value of D shifts all of our x coordinates to the right or left. So it's positive, so we're going to have a horizontal translation, which means shift or move to the right 3 units over. And this is going to be a vertical translation up 5 units. Okay, so move everything up 5 and to the right 3. So how do we do that? We just take what we did before, right, and we move them. So these will be our translations. All right, so what I'm going to do here is take my x-coordinates that I previously multiplied by 1 over k, and I'm going to add d. So I multiplied them by a half, and I'm going to add 3 to all of them. So this will be easy. -1 plus 3 is 2, 2.5, 3, 3.5, and 4. So I took all my x-coordinates there and added 3. Take all your y-coordinates, and we're going to add 5 to them. So, oops, here we go. So let's write that down. So I took my y-coordinates here. I add c. So what did we do with them previously? We multiplied them by -2, and let's add 5. So just take all of these numbers here, add 5 to them. So -4 plus 5 is going to be 1. Same with at the bottom. -2 plus 5 gives me 3. Same with there. And 0 plus 5 gives me 5. So we still have that V pattern, it's just been moved. So it's the same as this one we drew in blue. After we've done all our stretching and reflecting, we've changed the shape of it. Now we're just moving that shape to a new location. So that shape's going to move. Our middle is now at 3 over 5 up. So I'm just looking at the points in my table here. And then I'm 2.5 over 3 up. And on the other side, 3.5 over 3 up. And then I'm 2 over 1 up and 4 over 1 up. So there's those exact same shapes, points, just moved. And I'm going to draw my line. Okay, so you can see it drawn in green there. There's my final transform function. Now let's talk for a moment about the domain and range, something I forgot to mention in the previous video. So off our parent function sheet, our original function for the y equals the absolute value of x, our parent function, right? The domain of this would be x can be anything. We can input anything we want in. If we look at the graph, our range would be all of our y coordinates are greater than or equal to 0. But what about our final transformed function here? What's its domain and range going to be? There's different ways of finding this out, but for now, let's just study the graph. So for our final graph, our transformed graph, right, our domain doesn't change. If x can be anything in the original one, x can be anything in the transform function. That has no effect on it, okay? Now the y's, look what's going on here. We have a maximum. Look at the highest they go is 5. All of them are below 5. It goes down forever. So that means now of our y's are going to be less than or equal to the maximum, which is 5. That's the highest they can go. All right, so that's that one. Have a look at the next video and make sure you try any assigned work and practice these.